John actually did a session on mostly ETL processes, etc. And next we're going to talk about machine learning. And machine learning, one of the most important things to do machine learning is to get good ETL processes and get all of the correct data before doing machine learning. So if you want to have success at doing machine learning, a major percentage of this, 50%, 60%, whatever number you want to make up, it's going to be about doing the ETL process of preparing all of the data before you actually feed it to the training, to the machine learning training. So that's the most important part. And John was actually showing Azure Data Factory. I will show you a list of all of the tools that are available. One of them is going to be Synapse Analytics. We're not going to talk much about it today, but Synapse Analytics also has inside of it the equivalent of Azure Data Factory. So you can put everything in the same environment, so you can do the same things you saw for Azure Data Factory. You can do also machine learning. You can do other processes as well, all together inside. You can even do Power BI inside of Synapse, okay? Although this is not our session today, but I just want to give you a bug, infect you with a bug to actually go and see Synapse Analytics at some point in time. But anyway, our session is mostly about talking about machine learning and how to start with machine learning. So this is my cat that you saw just a few seconds ago, and this is usually me. I typically do a lot of different sessions which are very crazy, and I try to keep them crazy because, well, I'm crazy as well, so it's normal to do it. So let's start. Oh, it stopped. Okay, wrong film. This was supposed to be a different film, but anyway, this is mostly the theme should actually be 2001 and 2010, and most people probably already know who this nice entity is. It's something called HAL 9000, which was part of a film, and this is what's in the 60s, in the book in the 60s, then the film was considered the first, well, at least for fiction reasons, the first intelligent computer. Now, this session is not about making computers look intelligent. We have different things for that. I will give you a list for things that you can look at to make computers a bit more intelligent, but be careful because they might kill you. Some computers will eventually kill you. That's in all of the films. We know that this is going to happen. So please be careful. Just use machine learning normally to handle your data, to handle, processing images, processing whatever you want. But be careful. If the machines take over, we're going to be the first victims. Anyway, this is me. This photo was actually taken yesterday. Yesterday. So anything from me, you can go to andy.pt, and somewhere there you have links to all of the places, etc. And I have a link that's a link to all of my sessions, so you can go there and actually see all of my content. I am improving it, so it's in a temporary website. I am improving it. I've said that for 1,000 years, but hopefully at some point in time in the future it will be done. But currently it does have some of the more recent things. Anyway, let's divide this session into two parts. The first part is just to talk about what machine learning is, and the second part is to show you how you can use machine learning. So based on the information that we talked about, how you can use machine learning using Azure, but in whatever I'm going to say, you can use it somewhere else. It doesn't have to be Azure. It doesn't have to be a Microsoft product. You can just use it anywhere. Okay, so first things first, we need to understand where machine learning, where artificial intelligence is, and if you have your databases here, so obviously John just before me was talking about ETL, etc. So he was getting stuff from databases. Maybe you do some data mining, knowledge-driven design, etc. So you get stuff from here, and then you can take some of the information, and now we're going specifically into this area. You can take some of this information and use it for artificial intelligence, for machine learning, for other things which are very specific to the things that we're now going to talk about. Now, there's some overlap here, and the most important one I want to mention is the misconception that most people have about artificial intelligence and about machine learning. Artificial intelligence is a generic concept that just talks about a lot of different things. One of the things inside artificial intelligence is machine learning. So machine learning is just algorithms. So if you are a developer, you'll understand this very well. It's an algorithm. In most cases, it might not be deterministic. So the same result that you get in might not be the same as you get out, but statistically, it will be similar in terms of, accuracy between them. If you compare them, it will be 1-2% difference when you process them 2 times in a row. And there's a lot of reasons to do this. Some algorithms are based on finishing certain things in a certain amount of time. If that fails, they will give up after a certain amount of time because they process this, they process that. They don't seem to improve after a certain amount of time, so they will stop it. They don't see improvements. And because not all machines are running exactly the same way, the results might be slightly different. Statistically, they will be the same. Okay, artificial intelligence has much more things. So if you consider that you have self-driving robots or bots or cars or something, that's a different area of artificial intelligence. Machine learning receives information, processes the information. So basically, it's almost like an intelligent ETL, and then provides you with knowledge, which you can use to ask things, and provides you with knowledge so that you can use it to drive the robots or something else, but that's a different AI area somewhere on the site. Okay, there's obviously much more. One of the things I wanted to mention is, if you want to learn machine learning, you should know the basics of statistics, the basics of mathematics, but consider this: you don't have to be a PhD in statistics or mathematics to know machine learning. If you are the one designing the algorithms, well, maybe yes, but in most cases you are consuming the algorithms. So as a developer, you know how to do this. You have a class of something, and then you're going to use that class to do something, right? So you have SDKs, you have other things. You're just going to use them in those specific logic. So that's the easy part, of course, right? Now, what actually happens here is that in terms of statistics, in terms of maths, what I would recommend is that you have at least the high school equivalent of maths. It's usually enough for you to consume basic things in machine learning. If you want to be a data scientist, which is a bit more advanced, in that case, I would recommend learning a bit more about machine learning. There's a lot of books that talk about statistics, that talk about mathematics, but specifically for machine learning. I'm not going to recommend anything specifically. My recommendation would be, nowadays there's a lot of things online which are even free. So just start with those, get acquainted with those, and if you feel you need to learn a bit more, just have a look at some. I'm not the biggest expert in machine learning, but a lot of people recommend this book, that book, etc. Just go into those books secondly, okay? But first, try the simpler things, because in most cases for you as a developer will be more than enough. Now, I don't want to go into the details, technical details of some of these algorithms, but there are 2 divisions of algorithms. You have the supervised algorithms. So let's say you have a table, and that table has a lot of information. Let's say it's a bank loan. So that bank loan has information, each line is a bank loan. So person, age of the person, or date of birth of the person, this can be the thing. So you can have things like the date of the bank loan, but that's not interesting for you. The interesting part for you is not the birthday of the person. It's the age of the person when they ask for the bank loan. Let me give you a specific example on that. So let's say you go to a shop and you buy something in the year 2000. Okay, and let's say you were born in 1950, so that means you are 50 years old, and you buy something 20 years ago. Nowadays, and I still consider that we are in the year 2020 or something like that, because the pandemic freezes time for everyone. So 20 years later, someone else who was also born in 1950 buys the exact same products. Now, machine learning can do a lot of different correlations, etc. There's a lot of interesting things, so association, clustering, etc. But if you want to compare these two people that bought something 20 years ago and something now, so the same product, these are completely different people, because when they bought the product, and that's the most important thing, it's not their age, at least not in most cases, it's not their age, is that one of them bought the product at 50 years old, the other one bought the product at 70 years old. And those are completely different age groups. Okay, and if they are different age groups, that does not correlate with each other. These are probably completely different events. Okay, now let's say you take one of those tables and the table has a lot of information. Let's go back to the bank loan. A lot of information about the bank loan, where you work, how much money you make, how much money you have in the bank, the usual things. And then in the end, it has just a yes, no. It can be a 0 or 1, a yes or a no, whatever you want, A, B, something, okay? So it has just a field that tells you if you paid the bank loan, yes or no. True or false, something like that, just something very simple. Now, based on that, you can do machine learning. So 1 minute. Again, I have my cat, because as soon as my cat sees machine learning or anything Azure, she will start to meow and want to interact. So she's just here in my lap to be calm. Okay, so in space they don't have cats, they should. But anyway, let's say that you have the result column. When you do the training itself, what you're actually doing is that you are asking the training to confirm if when you run the training, the results will be correct or not. And then based on the results of the training, you'll have a percentage, which is how things are running. So let's say if the percentage, let's say the accuracy, there's other metrics, but let's use the accuracy. It's like a quality metric. So let's say if the accuracy is 90%, that means 90% of the time, based on the information that you had, when you do predictions to see if the person will pay the bank loan. So if someone is asking for a bank loan in the future, in that case, 90% of the time, the result will be correct. But in the case of a bank loan, because it's a long-term thing, it might take 30 years, 40 years. Sometimes this is not perfect. You based on the information that you can do, it's not going to be perfect. But anyway, those, because you already have the possible answers, and learn from something that already has answers, that's called supervised. And supervised might be something different. So you have no expectations of what the result is going to be. You just want to do some processing so that you understand what's happening. You can do clustering, association, etc. An example of this is the shopping part. So you want to correlate people when they do shopping for this product, for that product. You want to correlate age, you want to correlate everything, and you want to understand what's happening, but you have no idea what to expect. So that would be unsupervised. And they have different techniques like cross-validation and things like that to actually make sure that the results are good. But that's a different story. That's a bit more advanced that we want today. There's also reinforcement learning. So one of the things, besides this, one of the things you can also do is one of the expectations. So no matter what the algorithm is going to be, what type of algorithm, etc., one of the things you can expect is 3 months from now, 6 months from now, whatever the time frame, it makes sense for you to retrain your algorithm. Okay, so that thing will always happen as well. Now, going back to supervised, unsupervised, etc., we have a few examples. So regression, classification, and clustering. I have a few examples next to this. Neural networks are a technique that you use in which you define infrastructure. somewhere in your CPU, in your computer, in memory, etc., where you actually learn similar ways that you learn for the brain. Now, neural networks, there's algorithms for regression, for classification, for not so much clustering, but for regression classification, there's algorithms that actually use neural networks. So the concept here can actually be used in multiple different usages. Now, consider this: neural networks is supposed to be the best one, but it also takes much longer. Okay, whatever usage you're going to do, for instance, you can do regression or classification using neural networks, but that might take a long time. So you have to be careful, because you might just want something simple, and then neural networks will be very precise, will be very good, but it will also take you a long time. And in this case, if you have to pay more money, and specifically in Bangladesh, you have to pay more takas. Is it takas in plural? So that's going to be very expensive. But anyway, let's have a look at some of these algorithms to understand quickly how these work. Okay. By the way, I hope this doesn't insult anyone, but let's say that you are an alien coming into Earth and looking at this, and from a statistics point of view, this is true on average, because there's almost similar number of men and women, a bit more women than men. You have, let's say, 0.99999 something of this, right? The problem is that this makes no sense. You either have 2 or you have 0, or something in the middle. Let's assume. But from a point of view of statistics, the average is 1, and that's wrong. So from a machine learning's point of view, this will be a problem. Okay, this will be a problem. So I saw this online somewhere. I had to include this in the presentation because this is the most obvious one, although hopefully this doesn't insult anyone in that case. Now, let's get to linear regression. If you go to high school, and actually very early in high school, you have something called linear regression. And typically you put some dots on it. So let's say they give you 2 or 3, well, let's say 10. They give you 10 points, and you map the 10 points, and the rule is you have to create a line that goes from that tries to go around all of the points, so to be as close to the points as possible. There is a more formal mathematical definition. I'm not going to go into that. It's also simple, but typically when you were in high school, you try to draw a line, and then that line has some characteristics. Now, how does this work? Well, let's say you have a lot of points here, and this can be anything you want. So these can be temperature, this can be other things. Doesn't really matter, to be honest. But because you have all of the events happening here, all of the situations happening here, you draw a line, and this is the most accurate line between all of this. Let's say on average. Okay, keep it simple, on average. So what can you use to predict this? Well, you can predict very simple things. So simple trends of what's to expect. You can predict things like weather, economics, etc. Although, to be honest, some of these will use a bit more complex scenarios. The best thing about linear regression is that it's extremely simple to calculate and very fast. The other one will be extremely slow. Okay, but there's other things. So you have things like vector machine, etc., in which you actually get not a straight line, but a curvy line that tries to go around the points, and that might be a bit better. So you can choose the algorithms. I'll show you some of the algorithms just in a second, but in any case, the idea is exactly that. So you choose the best algorithm for this. This one is very simple. Now, once you do some ETL and then you do some training, the result of this will be something called a model. And that model is just a very small file. Let's say you start with 1 petabyte of data, so a lot of data, and then you end up with just a few kilobytes of model. In this case, specific for linear regression, this is probably the only one where you look at the things and you can understand what the variables that are inside that model actually mean. So one of the variables is the distance from the point 0 to the point, let's say, 25. I'm assuming this is close to 25. So that would be the distance, the distance at the axis. You also have another variable, which is the inclination of the curve. So you have something like A plus bx, right? So if you know A, which is this vertical distance, and if you know the B, which is the inclination of the curve, if you get the x, so let's say x will be one of these at the bottom, you get the y immediately. So all you have to do for that model is to have 2 values. One is A, one is B. And that's the simplest one you can understand. All of the other ones are very confusing to understand because those values are completely crazy. But this one is very simple to understand in terms of concepts. Now let's go for the next one, and the next one is something called linear regression. But before that, let me just say, so similar as the one before, if you take your data and try to use a lot of different algorithms to try to extract data that might not be there, you might end up with something like this, okay? And this is actually true. This is one of the problems, one of the fallacies with machine learning. You want so much for the data to be there that you can actually use some algorithm that gives you that results, and then it will be skewed and it will be a different data, okay? So it's very important for you to know your data, to know what to expect, okay? And then the algorithms will probably generate something that might be unexpected. So you shouldn't say that they are wrong. You should analyze before you determine that there's something wrong and come up with a different algorithm to fit your mentality of what you expect, okay? Because the result might be different, okay? But anyway, let's go for logistic regression. I have a very big cat here. I'm going to try to get rid of my cats because it's very difficult to do a session with a cat in my lap. Especially, you know, people in the 2001 film never had this problem with a cat next to them. But anyway, let's talk about logistic regression. Let's say that you have two possibilities. We talked about the bank loan, yes or no. So that would be a two-class model, okay? So yes or no, true or false, A or B. So it's always two. Well, this is okay. You also have three-class model, four-class model, etc., or multi-class model, as we usually say in general. There's good algorithms. Logistic regression is one of them, where you can use this for two-class models, and it's specialized, gives you very good results. There's other algorithms which are very specialized for multi-class models. So that means that they require that they are much better at determining multi classes, so three or more. However, if you use that one to determine two, it's also good, but maybe not as good as this one, okay? Now, let me take a different example. Let's say you are in school. This is about some kind of birds, African birds, European bird, and they compare the speed, etc. But let's do something slightly different that we can understand. If you go to university or high school, something like that, you have exams. And when you take an exam, you either study a lot. Let's say that this 1.5, 3.5 would be the number of hours that you study for the exam. Let's say it's that little, okay? So if you didn't study anything, the most likelihood is that you are in the lower category, which is you didn't study, you failed the exam, okay? So let's say that this triangle, blue triangle here is you failed the exam. Okay, if you studied a lot, the likelihood is that you're going to pass the exam, so that will be okay. However, even if you study a lot, you might still fail the exam. Even if you don't study anything, you might still pass the exam. Okay, so that can happen. However, how does this work? Well, based on this information, logistic and others, not just one, but typically multiple fields, they will try to analyze what's the likelihood of you passing the exam. Okay, now the average of this, the 50% average of this in this case, would probably be close to this dot here. It's not a vertical dot, it's actually horizontal, because this would be 100%, this would be 0%, something like that. Also, these values here are not at the bottom or at the top. These are a percentage that show up somewhere in the middle, but then you have to define something called a threshold. This will be a horizontal line here somewhere, let's say close to here, that you define that below this point I'm going to predict as negative. On top of this point, I'm going to predict as positive or pass or something like that. So when you do the prediction, you adjust based on the data. Sometimes it's not 50%. Sometimes it makes sense to be 60%, 40%, whatever the value is, because it depends on your data. Every data is different. There is no rule for this. You have to analyze based on your data. So when you have all of the scenarios, okay. Hello. Okay. Oh, no problem. Okay. No, but this is all right. So because I'm actually hearing Bengali speaking, right? So this is very positive. It can't just be English. Anyway, but don't worry. This is what happens in the last 2 years. All of the events, these are very confusing. The most typical one is something called, "Is my camera on? Can you hear me?" So this is okay. Oh, I cannot hear you.
Sorry, Andrew, for interruption. Your slide is not visible, actually.
My slides are not visible. Okay, so I'll unshare and share again. This is very strange. Okay, sometimes this kind of thing happens, but let's see. Is it visible now? I've just shared again. Okay. So but I am visible here, right? In terms of
visible, and
video.
I thought that you are just talking. Okay. You don't have any slide to view.
Oh no. So I am indeed sharing. Is it showing up as black or something like that?
Right, it's the black screen.
Oh, I know what the problem is. Oh, I'm sorry. I know what the problem is. I think I have an answer for that. I do apologize for this being strange, but I do have an answer for that, and it's a bug somewhere in Teams that honestly I cannot really understand. But give me a second, so I will try to solve this problem. That is okay. So give me just a second. I will try to solve this problem and join on Teams again. So give me just a second. Meeting info, copy join info. So I will try to join on Teams and okay. But this is very strange. Sometimes Teams has a bug for sharing the screen. Something that I honestly cannot understand why. But give me a second. Let me just see if I can join. Okay, on the page. Okay, this is very strange. And for some people, Teams, at least once you use Windows 11, for some strange reason, it stops working. It stops working for a lot of people. So give me just a second. Let me just find the link that you sent me, and I will try to join via 1 second. 1 second. I will try to join via the browser, because there is a bug which I honestly cannot understand why. There is a bug that does not allow that gives you an error while trying to share things. Don't ask me exactly why, but give me a second. So I will obviously share. Give me a second. Okay, so where's the thing? Give me a second. So copy link. I will try to share this here. Let's see if this is okay. Continue on this browser. I will try to share it. I do apologize for this. Okay, so I will try to speed up with this. Okay, so anyway, join now. So I will try to join as a secondary screen. Give me a second. Okay, so I will. Okay. So mute. Okay, so I will share this with my browser. I have had this problem before. It's some kind of bug with the Windows 11 and Teams. Sometimes it works, sometimes it doesn't. I honestly cannot understand why, but I've seen more people have this problem. Okay, so hopefully you are able to see this now, if that's okay.
No, right, it's okay. We can view your screen. Your skin is visible right now.
Okay, so it is visible now. Okay, so finally, okay, so we were talking about linear regression. Let me quickly repeat. So basically, you have a line. The line will have certain inclination to acquire all of the points as close as possible, and then you have a distance from the line at the origin, and you also have an inclination. This will be a plus bx. And you can calculate, if you get the x, you can calculate the y. So that's easy enough. That's linear regression. You also have another one, which I was going to mention. So the torture part, let me just mention the torture part. If you try to torture the data, it will confess something different. So this will be something that might actually happen. And we were going for logistic regression when you mentioned this. Sometimes this happens. It's perfectly okay. I will share the slides later. So if anything is missing in the beginning, I will definitely share the slides. It's not going to be a problem. But anyway, I was mentioning this. So if you are, let's say, here at the bottom, you might have some negative values and some positive values for the exam that I was mentioning, for instance, or for the bank loan or for something like that. In this case, this might not be the best example because the concentration is very strange. But in any case, let's say that you try to take the exam, you study a lot for the exam, let's say 3 hours, and then you still fail. Or if you don't study anything and then you still pass. So it happens. But one of the things that will happen is that these triangles will not be here at the bottom or at the top. They will actually be vertically in the y-axis, let's say from 0% to 100%. So 0% will be A and 100% will be B. This can be true, false, etc. This can be yes or no. It's two classes, so two classes can be anything. Plus, one very important thing to mention: the true class does not need to be the 100%. And the false class does not need to be the 0%. It can be the other way around. So the true one can be the 0%, and the false one can be the false one can be the 100%, and the true one can be the 0%. It depends greatly on how the training is done. Okay, so you have to be careful to make sure that you analyze things properly and don't confuse the yes with the no and vice versa. Okay, but anyway, this is usually a percentage. Okay, and as I mentioned, there's usually something called a threshold, which, let's say on average you start with 50%, and then you can decide that it makes sense for the accuracy to put it at 60%, 70%, 30%, 40, etc., because of the data that you have, which is slightly different. Okay, so anyway, besides this, you have many other algorithms related to this kind of concept. So remember, linear regression and regression in general refer to things like you have a line, which can be a linear line, so a straight line, or any other kind of vector machine that has different lines of function for different style of lines. Or you can also have logistic regression, in which you have two classes, true or false, or A or B, or something like that. You can also have multi-class, but I'll show you some algorithms of that just in a second. But you can also have other different things. One of them is, and this one can be used for regression. This can be used for classification, etc. This is something called a decision tree. This is how machines can learn. So let's say that there was actually a game called, I'll show you this in the next slides. 1 second. This is called 20q.net, which is a game where they start asking you questions, and then they will construct a tree based on your questions, and they will try to give you an answer. Now, this would be a tree similar to this. So you start with some way to classify people, and this can be a classification, but you are using something called a decision tree. So based on the information you are receiving from the users, this can be tables and things, or this can be interactive. It's whatever you want. You can say, let's say the first question is, and by the way, this, you can put this into a table. I've actually created this kind of algorithm like 20 years ago. You can create the algorithm so that this can learn very quickly. I've created this like 20 years ago in Access with a simple table and maybe 20 lines of code. This is very easy to create. So let's say that the first question is it a mammal? So if it is yes, you go left. If it is no, you go right. This can be replaced by simple, lines in a table. It's not really a problem. So if you say yes, in that case, do you use it as a pet? So yes, well, I'm thinking about a cat, let's say, but they consider that this is a hamster. Okay, so if you say no, is it a farm animal? So if it's yes, it's a goat. Okay, if it's no, might be an elephant. Okay. So anyway, let's say that I'm assuming my cats. So people keep it as a pet, so it's a hamster. So from a computer's point of view, if you win the tree, it's a hamster. Okay, it's not true. It has 4 legs, it has a tail and things like that, but it's not true. So the question is, and the computer will tell you it's a hamster, and you say no, this is not true. So the computer will say, okay, what's the difference between a hamster and a cat? You can just say, well, the cat has whiskers. Well, actually, the hamster as well. Everyone has whiskers for some reason. So let's say that the cat meows. Okay, this is a good technique. Does it? So they will. The computer will add an additional question here, which is, does it meow? Yes or no. So if it's a yes, it's a cat. If it's a no, it's a hamster. But let's say now you have a dog. Does it meow? No. So they say it's a hamster. No, 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 it's a dog. And then you say, okay, so computer will ask you, what's the difference between a dog and a hamster? Well, the dog barks. Okay, and then you ask another question, does it bark? Yes or no? So you construct questions gradually, and you can have limits on these trees. So you can have limits on the number of total nodes in the tree. You can have a limit on the number of levels on the tree, so horizontal levels on the tree. You can have multiple trees, because remember, if you are doing decision tree, you can have multiple levels on a tree. Okay, let's go for the next one, and I'll explain this game very quickly. You can go to 20q.net. They started saying that you only had to answer 20 questions and they will get it right. Last time I tried this a few months ago, it was up to 32 questions or something, because they acquired so much information, they have so many trees inside, then they will not be able to determine the answer based just on that. They will try to guess after 20 something questions, but they will say, well, I can ask more questions and refine the answer. Am I close? Yes or no, etc. So the answers here are simple things like yes or no, unknown. This will be equivalent to I don't know. So we ignore that question from the point of view of the tree. Irrelevant, that would be a null, so not applicable to us. This is not part of our tree. This is someone else's tree. And then sometimes, maybe, probably, doubtful, usually, depends, rarely, partial. That would mean that instead of just going to the left or to the right to the yes or the no, you can actually assign percentages of accuracy based on, does this go to this one? Well, probably, but with 80% certainty, not exactly the same. So some of these maybe sometimes might be 50%, maybe might be 50%, but probably might be 70%, etc. So you can actually adjust the tree instead of just saying yes or no to the left or to the right. You can adjust it with some percentages of reliability on the answers of the questions. Okay, so there's a lot of tricks that you can do with this. Okay. Now, in the end, if you know SQL and if you know SQL joins, think about these kind of trees as you get a result. So you answer all of the questions and then you get the last result in this tree, but you also get the last results in a different tree and in another different tree, etc., because you ask to analyze all of the multiple trees and answer questions on multiple trees. In the end, you can do what, it's not the correct way to say this, but think about this as a SQL query. You need to do a join on the result of this tree with a join on the result of the other trees. Okay, so this is, it's not the way that it's done, but it's the concept is similar. Okay, so when you join everything together, you might get a result which might be the most expected results, and then the result will be a percentage of all of these things. Okay, so whatever option you decide to do, they will give you, there's a likelihood of 80% that the answer is this. Maybe it's a cat or something like that. Oh, sorry, maybe it's a cat. Am I guessing it's a cat? So right, wrong, or close. Okay, so close can be an option instead of right or wrong. So if it's wrong, it's just difference. If it's close, well, maybe I'm in the right set of trees. I'm in the right set of 2 or 3 trees around, but maybe it's something similar. So I'll ask a few more questions. Okay, so decision trees are actually used in all of these models, like regression, like classification, mostly classification, but they are used in a lot of different things because they are an easy way for you to detect things, especially if you have things like questions like, did you pay the bank loan? The result's going to be yes or no, but then you have things like, what's your job? And your job is not a number. It's going to be, I work in IT, or I work in, in McDonald's or something like that. So those will be not transformed into numbers, but those will be questions. Do you work in the food industry? So McDonald's, Pizza Hut, whatever that is. Do you work in IT? So are you a developer, etc., etc. So they can fill the tree with detailed questions. Okay, I also want to talk about one last algorithm just to give you an idea. One of them is called clustering. So you have algorithms for you to understand what's happening with things. So this can be clustering, association, etc. In the case of clustering, there's one typical algorithm which is older than me. It's somewhere from the 70s, which is called k-means. Now, this algorithm was changed over the years to include some optimizations. Now it's much more optimized than the 70s, but still the concept is the same. So let's say that you have one metric here and you have another metric here. You can have three metrics if you want and be three-dimensional if this is something that you want, or fourth-dimensional, etc. So instead of making a circle like you see here, you make a sphere or something like that. So the idea here is to aggregate inside of these spheres, is to aggregate what they call clusters, okay? So you aggregate similar situations. Now, if you go to a supermarket, people who buy wine also buy something, cheese or something like that. People who buy bread also buy something else. Exception, people who buy toilet paper, they are desperate because of the pandemic. That's an exception. If you go for those normal things like toilet paper, like other things like that, there might be no correlation whatsoever. It's just something that after a few months you need to buy it, but it might not be related, you know, toilet paper might not be related to buying wine or buying something else. Maybe you go there once a month and you buy everything once a month. So every time you buy wine, you buy toilet paper, and you might think that they are correlated, but they are not, because simply this is just the time of the once a month or something that you go and buy the most amount of shopping, and the other times you just go there and buy bread or something like that. So might not have actual relationship. So it might not be a need, a thing that you need relationship. It might be a thing that's it's convenient relationship. So it's a different kind of relationship, or no relationship whatsoever. It can also happen. You're buying toilet paper for someone else who's at home with COVID or something. This happens, okay? This is perfectly normal. So how does this work? Let's say you have one metric on the bottom, on the x-axis, and one metric on the y-axis, okay? So let's say that's average households power consumption, and then peak household something. So one person is going to be here, another one here, another one here. So there's clusters here, whatever they mean, that people who buy this also buy that or something like that. So you aggregate into some things. And when you aggregate, you know that these people have the same thing as the other people, okay? So you can suggest, if this person bought something, you can suggest the same thing to the other person. It might work. Now, this can go terribly wrong. One of the examples of this is there was a story probably in the United States, but I can't guarantee, that someone started to receive from the supermarkets suggestions about buying baby stuff, you know, baby bottles and, I don't know, diapers or something like that. And the person was very didn't know what happened, and a few months later she discovered she was pregnant. Okay, so she sued the supermarkets, very, very typical sometimes. She sued the supermarket because the supermarket was infringing on her, let's say, privacy or something like that. In reality, well, I can understand the problem. Of course, this is a sensitive area, but in reality, the computer was just following the example. So this person did not know that she was pregnant. So she was buying things that she wanted. You know, she went to places, oh, I want to buy this. And other people were also pregnant at the same time or something, were buying the same thing. So they were put in the same cluster. And suddenly the bot understood that those people, after a while, started to buy something. And they correlated that into that person, but that person was very upset. So there's also a scenario here about privacy, about you know, privacy intrusion, etc., that can go into this. But in reality, the algorithm is kind of blind, because the algorithm has no idea that person is blind, just recommends based on, you know, metrics and things like that. Okay, so it's impossible to avoid this kind of problems. Anyway, how does k-mean work? Well, it's very simple. You start with putting centers or centroids in, so 2 or 3 dots, in this case 5, okay, one for each circle, and then these dots will try to get the closest So for each item like this, you will try to associate it with the closest possible center of this thing. And then based on that, yeah, this is the first step. So all of these will be classified as, let's say, A, B, C, D, E, so 5 in total. And then once you do that, you move the center to the average of all of the results that you get for all of these. And then you try to determine the distance between all of them again. And then you move, some of these might move, let's say, from this one to the left, and so on. So it might move a bit. And after a few iterations, let's say 4, 5, 10, whatever the number, nothing is going to change. After a while, things stop changing because that means that they are in the right place. That's the k-means algorithm. It's very simple to implement. It's not difficult, okay? Nowadays, they optimize it so that they have less iterations, etc., because you might be handling, gigabytes of data, petabytes of data even. So that means you need to optimize this a bit faster. Okay, now remember one thing. If your result is 100% correct, you're not doing AI, you're not doing machine learning, you're probably doing ifs or SQL where clauses, so it's going to be different, okay? Anyway, this ML cheat sheets, I'll actually post the link here just in case, okay? So the link here, but in any case, if you are watching this video later on, this will still be similar, okay? So you go to aka.ms, so this one that you see here in the bottom, ML cheat sheets that you see here in the bottom. I put the link on Teams just in case, but basically what you have here is very simple. So let's say you want to predict 2 categories. So you start here, of course, 2 categories. So 2-class classification. You have support vector machines. So I talked about this. These are mostly for analyzing all of the things close to the curves. You can do 2-class something, and as soon as you see 2-class something, that means it's a 2-class classification. You get the result of yes or no, A or B, something like that. But you can use logistic regression. So we talked about this. You can also use decision trees, decision forests, etc. You can name it whatever you want, tree related. There's trees, forests, jungles, whatever. Anyway, you can also use neural network for this. So basically you want to get to 2-class, but you are using a neural network algorithm, which is very optimized. Anyway, for multi-class, you can use slightly different ones. So multi-class logistic regression, etc. So some of these are more optimized for A, B, C, or D, as they say here. This would be just for A and B. Image classification, you also have a few of them. Most of these will use neural networks. When you handle images, neural networks is the ideal scenario. You also have things like some recommenders. You have things like clustering. So k-means is clustering. There is 1 or 2 more, but 99% of the times you use k-means. You want to predict values, so temperature values, things like that. You use regression, so use any of these. So linear regression, Poisson regression, and then you have Bayesian regression. This is actually very good. The things that you see here are important. So linear model, that means that if you have more data, the amount of memory that you need to use will grow with the amount of data. If you have 1 gigabyte, let's say you spend 1 gigabyte of data, you spend, I don't know, 500 megabytes of RAM, let's call it like that. However, if you have 2 gigabytes of data, that means you use twice as memory, so 1 gigabyte of memory, okay? So it's linear in terms of growth. Some of them are not linear. Some of them will go exponential, and that's a problem. Some of these, you have to read what's here as a help, because they will tell you what's the best one. So accurate, and then long training times, fast training times, and then large memory footprint. This is going to be terrible. Okay, so this is mostly the problem. Anyway, text analytics, you have a few more, etc. But all of these, just read from the details what to expect. You can actually replace one with another, so this is perfectly okay. So let's actually move on. So a few months ago, 1 year ago, you had a lot of monoliths. So all of these, they showed up somewhere else. And because this is the 2001 let me just say that in the United States, this monolith is typical. Here in Portugal, this kind of monolith to get to a shower is also very typical as well. But anyway, let's go to the Microsoft world and see what we have. So you don't need, as I mentioned, you don't need to be a data scientist to play around with it. Okay, so how does machine learning work? So let's say you get, first part is the ETL, you get your data sets, and this is the same as the session before. You get your data sets, you clean them up, you prep them. Let's say prepping, an example of prepping, feature engineering, etc. Let's say an example of this is you have a date of birth. That's not right. You want to subtract the date of birth from the date of the events and then see the age of the person during that time, because you want to get the age. And then you aggregate ages by age groups. So let's say every 10 years, so from up until 18 years old, that's one age group. So that's kids. Up to 25, that would be university, etc. 25 to 35, 35 to 45, and so on, over 65, etc. So you can separate this into different groups. So let's say group A, B, C, D, etc. So you separate them into groups so that it's easier to aggregate them and say that these are probably common. Okay. Anyway, then you do the training, so you can use any of the things you want. So regression for a value, a continuous value that you want to detect, temperature, you want to detect something like that. Classification, so two-class, multi-class. Clustering, you can also do anomaly detection, although some of these algorithms for anomaly detection, you can use the normal algorithms and get the results, but there are specific algorithms for anomaly detection. Okay, if your objective is not to get the normal values and then also find anomalies, your objective is okay. So can you hear me? So something very strange happened. So my computer crashed with the blue screen of death.
No, it's okay.
So this happens. So just give me 1 minute. I'll show you a few more slides.
Okay.
Because of the lateness of the hour, we might not have time to actually see the demos. Okay, but unless you tell me that we can do a bit more time, but let me just start the screen and join again in a different in 1 minute. So the computer is just booting up, and then I'll show you some of the remaining slides just in case.
Sure, Andrew, sure.
I do apologize for this. This is actually not very difficult.
It's okay.
You can see my kitchen from the back. I am on my phone, but this,
Right.
so let me just do this. So I'll set the phone at this moment, and then I will try to get back to my PowerPoint. Okay, but the good thing is that we are using Teams, and because we are using Teams, I am able to join via the phone and say something went wrong. So this, okay. So give me a second. I will join this immediately on Teams. It's just a few seconds to join. So Teams is actually opening up. You know, this takes a long time. So let me just say restore.
It's okay, Andrew. No problem.
So I think the best way is I'll show you just a few slides at this moment. And then in terms of demos, I do have some pre-recorded demos that I have in the last few months, etc. So maybe the best option is for everyone to oh, so sorry. One second. This is very strange. So mute. Okay. So give me a second.
No problem.
So this
I have we can arrange a part two session for next month, say for user including demos and other things that you want to show. And
this will be maybe just to finish. I think that the best way is to just show you 2 more slides. I think that would be the best.
Take time, please.
I'm joining now. Hopefully okay, so so let's say speakers. So hopefully I am. Can you hear me now again? Is this okay?
Yes.
Okay, so give me just a second. I will join again on this. I do apologize for not doing the demos. I actually spent some time preparing these demos for showing in Azure. So it takes a few hours to prepare them and to start them, etc. But let me just join on Teams at this moment. So let me just share my screen. 1 second, please. Let me just share my screen. So restore. So I am on Teams. Give me a second. Teams, Microsoft.com. So I'm just joining now. Give me just a second, because I do apologize. This sometimes happens. I'm using Windows 11, and Windows 11 seems to be having a lot of bugs, really a lot of bugs. And Teams, hopefully the new version of Teams will be a bit better. But so far, I'm not seeing any real or nice improvements. So I'm joining now to share the screen as well. Okay, so join now. Okay, so I'm joining just to share the screen, and let's see 1 or 2 more slides, and then we'll be okay. So anyway, desktop window, share it, screen 2, share screen 2, share. So hopefully this will be okay. 1 second, my phone is already saying stuff. Okay, so I think I was here when this crashed completely. Sadly, in the video, you probably don't see the green screen of that. I'm actually using Insider Build, so it's a green screen. But in any case, let me explain the concept here. So preparation, as I was saying, might be something that you get when you change, let's say, birth dates into actual age or something like that. So this makes perfect sense. In the meantime, you do any kind of changes that make sense. You group people by any kind of aggregation, anything like that, which is okay. And then after that is done, I've just changed my background for this as well. After that is done, you do the actual training. So now the background corresponds to what I saw on the computer, except the smiley was negative. But anyway, then you do the actual training. This is fine. It might take a few hours, even months, in some cases, if it's a big training. Also, the cleaning might take you a long time because you have to specify what you want for cleaning. The cleaning itself is usually fast, but you have no idea what to expect. So the preparation part in terms of human work might take even more time than the training, because you have to adjust things because they didn't work okay. You have to adjust things, etc. So training might take a few minutes, a few hours, a few days even, and then you do some scoring and testing. So what is this? Well, let's go here. So you start with something, you change something, you split the data because you just want certain amounts of data. You normalize the data, so that's the cleaning, etc. And then you split the data into typically 2 parts. So on the left, you have the data that you use for training. On the right, you have the data that you use for testing. There was a bit more, but I don't want to go into this one. And then you have, let's say, the algorithm that you want to use, and then you point it to this one is tune hyperparameters, so it's a bit more advanced. But typically here is you have something that says train model, okay? Just a box that says train model. So you'd receive the algorithm plus all of the configuration in the algorithm. You would also receive the data just for training. And once that is done, that will generate your model. The model goes into here, and then the score model will try to predict things based on that model file. So a small amount of data variables, etc., that are used for predicting, and then that scoring is actually literally what you do here. So you try to predict things, and the testing part is getting the data for testing into here and trying to figure out the percentage. Let's say this can be a percentage or a different metric. Okay, let's say accuracy would be a percentage, root mean squared value would be a value which you want the shortest possible value, but the closest to 0 possible will be the best. Okay, so it depends on the metrics, on the algorithms that you use, etc. There's also something called hyperparameters, which is the configuration that you put here. So if you are using a decision tree, for instance, you adjust the number of leaves on the tree, the number of horizontal levels and things like that, number of trees as well. So you can also adjust the number of trees. So there's a lot of things associated with this. Finally, last but not least, once you score the model, you compare it with the original values, and the evaluate box usually handles the comparison of this. Now, this one is graphical because in Azure Machine Learning, you can actually do graphical interface, but there's also code using Python, using R, etc. But you also have AutoML. So AutoML, you just get the data in, all of this is processed for you, just get results. Now, once you do that, and once you do the evaluation, you can actually create a separate one, which is a web service, a predictive web service, or you can use this as a batch. So you just have the file and then you use it once a day or something like that. But this one would be in real time. So you can use this in real time. Every time you want to predict if the person will be okay with the bank loan, you go to that web service, you enter the information for the person, and then you get the results. Okay, so and then you do retraining again and again and again as much as often. Now, this is probably the most important slide I wanted to show you about the Microsoft worlds. Okay, so you have something called Azure Machine Learning, which is the Azure Machine Learning Service or the Azure Machine Learning Workspace. There used to be something called Classic. It's not that one. Okay, now you have an SDK into this that actually allows you to run things from your computer or from the cloud or from anywhere else, but actually manage things. You have something called Hyperdrive, so you can use multiple trainings at the same time with different parameters. There's a model registry where you can store the information about the saved models so that you can use them again in the future and decide on the best one. So I have 3 or 4, I decide on the best one, and then I deploy the web service based on the best one. You can deploy the web services in containers, Azure Container Instances, Kubernetes, etc., or even deploy it yourself in a cell phone or in an IoT device or something like that. Now, this machine learning is probably the one you want to try. This is very simple to try, okay? But there's more. So there's Databricks, and Databricks uses something that we talked about before in the previous session, which is Spark. Okay, so Spark clusters usually use a lot of memory to handle these kind of things. So you can use Spark on Databricks. Databricks creates a layer on top of multiple Spark clusters that you can just create. HD Insights, you can also use Spark, but it's only one cluster. So it's a bit obsolete, not obsolete, but old. Nowadays, everyone uses either Databricks or the ideal Synapse Analytics, which would be the one that I would recommend. Okay, so but anyway, you also have HD Insight R server if you want to use R server, but Synapse Analytics is the one that has things like everything related to Spark, which you can use for machine learning, everything related to the Azure Data Factory. So you have a copy of Data Factory, you have a copy of not a copy, but you have the usage of using Power BI reports directly from there. So that's easy to develop everything in one go. You also have a data warehouse where you can store data, etc. So this is very practical. Plus you have links to Cosmos DB and now to SQL databases and things like that. Besides that, on premises or even in the cloud, you can install SQL Server 2016 or 17, 19, 2022. The most recent ones actually have an R and Python services, so ML services for both of these. I can tell you that from my experience in the last few years, people are moving away from R and just using Python. So my recommendation is use Python now. If you are starting up with machine learning, use Python, okay? Some typical libraries for Python are things like scikit-learn, PyTorch, TensorFlow, etc. TensorFlow is actually used in a lot of different languages altogether, even Node.js, etc. So it's actually very easy to use. Okay. So last but not least, if you use different things, you can even use ML.NET, which is basically a library, because the trick of all of this is to use libraries. So all of this, Python is an ugly language, R is an ugly language, but it has amazing libraries. So ML.NET, you can use .NET language if you know it, and then use the libraries for ML.NET and solve your problem. And then besides the usual ML stuff, you also have cognitive services to do face recognition, but these are already done for you. You don't do any training. You just consume the services. You can have bots, you can have Power Virtual Agents, etc. These are all very easy. Now, most of these from the beginning, you will need to use something like notebooks. So these can be Jupyter notebooks, Zeppelin notebooks, mostly Jupyter, Databricks notebooks, etc. But you can use them directly there, or you can, do whatever you want. It's just easy. Okay. So having said that, I do apologize for running a bit out of time and not having time for demos. I do apologize for this. I would be happy to come back and do different demos if you want me to. But I know it's probably dinner time and you are hungry and things like that. But I'm not sure if anyone has any questions. But in any case, even if you're just seeing this video later on or something like that, I would be very happy to answer any questions just by send me a message. Just go to andy.pt, see any of my contacts in andy.pt, and you will be able to interact with me on social networks, so Facebook, Twitter, LinkedIn, whatever. Feel free to reach out, and I will be happy to answer any of the questions that you have. Okay, so in any case, thank you very much for being here. I do apologize for a lot of these technical errors. Most of these I can blame them on on Windows 11, but thank you very much for having me here. Thank you, everyone. Oh, wait a minute. Oh, we cannot hear you. We cannot hear you. You are muted.
Andrew, thank you very much. And actually, it's a fantastic session. And for the beginner, I think there is an option to take some few sessions so that we can be at expert level.
I would be happy to help, of course. By the way, let me just say that last week there was something called Global AI Bootcamp. This might be interesting for a lot of people watching this session. This year, I've actually hosted Global AI Bootcamp here in Lisbon. So we had a full day of sessions with people who actually came from different parts of Europe. So they actually came to Portugal. Others just did this remotely because of COVID. But we're going to have some videos. So these are not my videos. These are from everyone else. We're going to try to publish those videos so that people can see them as well. But in general, a lot of other people also had sessions all over the world, more than 60 locations. So if you want to see videos, this is a great time for you to see videos about Azure Machine Learning, about the Synapse Analytics, about all of these things. This is a perfect time. Just go and look for Global AI Bootcamp. Have a look at all of the videos that all of these people produced. We'll also make them available, eventually soon in a few weeks. Maybe at most we'll have to process them and make them available. But apart from that, just have a look at them. They are amazing. Last year, I also did a Global AI Bootcamp, specifically Global AI Bootcamp Singapore. If you go to andy.pt/doc, about a year ago, you actually have a workshop that I did to talk about Azure Machine Learning. There are some different things a year ago, but if you want to have a look at some of the demos, etc., this is a good place to start. I have 2 sessions on that event. Just go and see the videos. They will help you a bit, and they will, complement the things that I was not able to show today. But in any case, things change. So 1 year ago, things were slightly different. They have more things now. Nowadays, things will change. If I do another session in 1 month, another thing will change again. This will be completely different. So this is good, and this is normal.
And one thing, can you share your links and slide? So if you share your links or slide, and I will share it to the event page and other meetup tweet, so that the audience will get the flavor.
Okay, so if you go to andy.pt.
Okay.
Oh, wait a minute, not HTTPS. HTTPS, this is always important, but the guy memorized without HTTPS. So if you go here, just click on this link. The address is really, really old, but just go on this link, and you actually have presented sessions, etc. I already have one or two this year, but I will need to update it. But at least last year, everything's done. And you have some videos here, so you can click on the video links. All of these videos are already available, mostly on YouTube, but they are available. Some of these have slides, scripts, etc., so they will be available. And give me until tomorrow or something like that, and I will try to add this to the list here as well with all of the slides, etc. The one I was mentioning is Global AI Bootcamp Singapore 1 year ago, so they actually had some. This video is about 3 hours, and it talks about some of these things, so it repeats some of the slides that you saw before. So I think that this will help in terms of demos. Things have changed, but not that much, so you can still understand the concepts. So this is a good one to see for about 3 hours, and talks about a lot of different technologies. So all of that big slide that I've shown you talks about most of those technologies and gives you some demos, etc. So good one to get started. Okay.
Thank you very much, Andrew.
Okay.
Your session
thank you very much, everyone.
helpful to get a start into the machine learning.
Okay, and thank you to you specifically for inviting me. Thank you very much. This was a very kind invitation. But also thank you to everyone that watched the session live, and especially also to thank you everyone who will watch the session recorded later on. Feel free to reach out at any time to andy.pt, and all of my contacts are there. So feel free to contact me at any time. Okay. So once again, thank you very much, and hope to see you soon. Thank you.
Thank you very much.
Thank you very much.
Thank you. Thank you very much for the audience. We are very much thankful to our speakers who have taken the sessions, and we expect that the sessions are very much helpful for your career and as well as your company. And we expect that the sessions will be bring you to the next step in context of machine learning or Azure Data Factory. And we expect you join this session, join our tech community session that is arranged in every month, and we are expecting that in next month we will going to arrange another event in 19th of February. And till now, thanks to everyone for attending the session. Thank you very much. Goodbye for today.